we go. Super excited about this one. Radicals. This is the review. We're going to talk about simplifying. We're going to talk about adding, subtracting, multiplying, dividing. The whole gamut. Whenever we have a radical, whether we are simplifying, whether we are adding, subtracting, multiplying, dividing, we're always going to ask and see what type of radical is it. We got to check three things first. First one, is it a perfect square? Second one, is it not a perfect square, but can it be not perfect square, but we can simplify it? And then the third type of radical is not a perfect square and can't be simplified, so it's already simplified. It's already simplified. So when we look at rad 80, is rad 80 a perfect square? Nope. We should already at this point know the perfect squares of 1 through 15, or 225, shall we say. So if it's not a perfect square, can it be simplified? So we're looking for factors of 80 that have a perfect square factor. So we're going to keep it simple. Let's do nice and easy. I know 4 is a perfect square, and I know it goes into 80, and it goes into 80 20 times. So notice I broke it into separate radicals. Rad 4 times rad 20 gives me rad 80. I picked rad 4 because it's a perfect square. So square root of 4 equals 2 rad 20. Now I'm going to break that rad 20. And I'm going to go through this. I'm going to look at this radical. Is there a perfect square? Is it not a perfect square but can be simplified? Or is that radical simplified? So each time we're constantly going back to these three questions. So rad 20, I'm going to break into rad 4, rad 5. Rad 4 is, square root of 4 is 2. Now these 2's are on the outside, so I'm going to make this 4 rad 5. Now I'm not done. I'm going to check. Is rad 5 a perfect square? No. Is it not a perfect square but can be simplified? Factors of 5, there are no factors of 5 that have a perfect square in it, like when I did rad 20. So is it simplified? Yes, rad 5 is simplified. So my answer is 4 rad 5. Is 4 rad 5 an answer? A multiple choice answer? Yes. So this is what we're doing each time. Rad 100. Well, rad 100 is a perfect square. So I know that I should recognize those perfect squares. Perfect squares, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Those are the first 15 perfect squares. We should know those by heart. Rad 18, not a perfect square, but does it have a perfect square factor? Yes, 9 is a factor of 18. Square root of 9 is a perfect square. So I break it into 3 rad 2. Ooh, now we see, we have a variable. What do we do with variables? Well, remember, when things are being multiplied, we can break them up into their own radicals. So I'm going to look at 640 differently on how I'm going to look at the square root of x to the third. Our objective continues to be looking for perfect squares. 64 I see in there. So I'm going to break 640 into 64, rad 64 times rad 10. Square root of 64 is 8. Rad 10 cannot be simplified. Now, remember why we liked perfect squares. We liked perfect squares, for instance 64, was because that was equal to 8 squared. And the reason why we like that, because what gets rid of a radical is a square. So a square and a square root cancel each other. So when I'm looking at this variable that is cubed, I'm going to break them into squares. So I can write x to the third as square root of x squared times the square root of x. X squared times x gives me x to the third. And the reason why I broke it into those two is because this is a perfect square. We have a square and a square root. So that was my objective here. So if I could split it up, this is going to square root of x squared gives me x, and square root of x can't be simplified. So I'm multiplying these two values, and I'm going to combine the outsides with the outsides. I have 8 on the outside, I have x on the outside, and then I'm going to combine the insides with the insides. So I have 10 on the inside and x on the inside. So this becomes 8x times the square root of 10x. 8x times the square root of 10x. Pretty simple, nice. Let's separate them. 216, p to the fourth, 216. I'm sure that that's probably a perfect, no, that's not a perfect square. So I'm thinking of factors. So I'm thinking of 4, 9, 6, 9 goes into 216. Do you know how I knew that 9 goes into 216? Because 2 plus 1 plus 6 is 9, and the 9 rule is that. So I'm going to break this into the square root of 9. 9 goes into 21 2 times. With 3, 9 goes into 36 4 times. All right, 36, 3, 18, yes. So this becomes 3, we'll write it over here. Rad 9, rad 24. Square root of 9 is 3, 24, I see a 4 in there. So this becomes 3 times 2 times rad 6, or 6 rad 6. Now let's break up p to the fourth. Well, I know that 2p squares equals p to the fourth, so that's going to be p times p outside of the radicals times p squared. So my answer is going to be 6p squared. These are outsides, and rad 6 is on the inside. So 6p squared, rad 6 is b. All right, another big one, 343, 343, and square root of r squared, 343, 3, 4, 3. What can we break that up into? Does 4 go? No, 4 doesn't go into that. 9 doesn't go into it. 16. No, 16's not going to break. Well, 343. I think 11 goes into that, and 11 goes into that 27? 27? No, not 27. Hello. No. 3. So it's going to be something with a 3. Wow, this is a good one. This is a really crazy one. So it's a great opportunity. So remember my rads: 1, 4, 9, 16, 25, 36, 49. I'm going to try 49. So 3, 4, 3 divided by 49, 7. Knew it. All right, so rad 49 times rad 7. Square root of r squared is just r. Square root of 49 is a perfect square. That's why I chose it. So you have 7 rad 7 times r, and you have 7r rad 7. There we go. Not too bad. Took me a little bit. Threw me a little curveball. All right, now we notice these problems. Now we're on problems that have coefficients. So when we do simplify rad 20 to rad 4, rad 5, this square root of 4 becomes 2, and we already had something on the outside, so we're going to combine those outsides. So we get 6 rad 5. Same thing here. 343 again. Look at that. 343 we know is 49 times 7 Square root of 49 is 7. Rad 7, that's 63 rad 7. I think they like C as an answer. Look at that one. Square root of 1,000. Well, I'm going to do 100 times 10. Square root of 100 is 10 rad 10. And we get 90 rad 10. 90 rad 10. Ooh, look at that monstrosity. 216 x to the third. So we're going to separate them into their own radicals because we're going to treat them a little differently. 216, I know I did 216 earlier. 9, yes. 9 goes into that. 9, and that went 20, I think 24 times. And x to the third is going to be x squared rad x. So we get 10 times 3, because 9 is a perfect square. 24 I'm going to turn into 4 and 6. Square root of x squared is x. Rad x can't be simplified anymore. I got another perfect square here. Let's make that 30 times 2 times rad 6 times x times rad x. And let's combine all the outsides. That's going to be 60 x rad 6x. Insides with insides, outsides with outsides. 60x rad 6x. Did I circle that one? Yes. Good. That was number 10. 11. 72. 72. That's not a 72. 72x to the third. So I know that 9 goes into 72 8 times. X to the third. So 2 times 3, 8 can be simplified to rad 4, rad 2. That's x squared x. That is 6 times 2 times rad 2 times x, rad x, excuse me. And outsides give me 12x rad 2x. 12x rad 2x. B. 10, whoop, yeah, that's okay, because that's what's happening in between here. There's a multiplication between those. Times n, rad n. Let's break 400 into rad 4, rad 100. I love that. It's a perfect square. And then the square root of n cannot be simplified. 10 times 2 times 10, which is 200 rad n. 200 rad n. C. All right, now we should notice, hey, let's put the brakes on. Notice we switched types of problems. Now we're adding radicals. And when we add radicals, we need to have like radicals. They have to have the same radical. They have the same radical, which they do. We're going to combine their coefficients. These two do. So 3 plus 2 is 5 rad 2. The radical stays the same. So we're not going to, that doesn't pop out. Rad 2 plus rad 2 does not make 2. It's only in multiplication, but we're adding, so we should be very aware of that. And my answer is going to be 5 rad 2. We have like radicals, 3 rad 5 minus. We can see that as 1 rad 5. There's an invisible 1 in here. And so we have like radicals. So we're going to combine their coefficients. 3 minus 1 is 2 rad 5. 2 rad 5, D. We have negative 2 rad 2 minus 2 rad 2, like radicals. So we're going to combine their coefficients. Negative 2 and negative 2 makes negative 4 rad 2. Number 16, now we have 3 terms. 1, 2, 3. Let's just combine the first 2, or let's see if we can combine the first 2. So we have 2 rad 6 minus 2 rad 6 plus 2 rad 6. Let's just start with the first 2. Are they like? Yes, they are like. They have the same radicals. let's combine their coefficients. 2 minus 2 is 0. So these are going to cancel out, and we're just left with 2 rad 6, making sure that rad 6 can't be simplified. Because remember, whenever we have a radical, we're always going to look to see if it's one of those three. So my answer is going to be B. 17. So same example, we have negative 2 rad 3 plus 2 rad 6 minus 2 rad 3. Can I combine these two? No. Those are unlike radicals. They're not the same, so we can't. These are unlike. So we can't combine those coefficients. But we do have a pair of like radicals. We have rad 3 here and rad 3 here, and it's adding and subtracting amongst the three terms. We can't combine those if one was being multiplied, one was being added, blah, blah, blah. But because we are adding and subtracting these three terms, the three terms are this, this, and this, that means we can combine these two coefficients because they are like terms. So you have negative 2 and negative 2, which makes negative 4 rad 3. And then we can't forget that one unlike radical, which is 2 rad 6. So I can't combine those because those are unlike. So my answer is going to be A. We have negative 3 rad 5 plus 2 rad 3 minus 1 rad 3. These are like terms, so we'll combine their coefficients. I don't have anything to combine with the negative 3 rad 5, and that gives me rad 3. Notice I did not write a 1 in here. I can write the 1 while I'm doing my work, but in my answer, I'm not going to write that radical. Number 19, negative 3 rad 3 plus 2 rad 20. Minus rad 27. So remember what I said. We have to make sure, and we have to be aware that some radicals can be simplified. They look like three unlike radicals, but we can simplify rad 20 and we can simplify rad 27. So we get negative 3 rad 3, which is simplified. Rad 20, I'm going to break into rad 4, rad 5. So that's 2 times 2 rad 5, which is negative 3 rad 3 plus 4 rad 5. So that's simplified. Let's deal with negative rad 27. I'm going to break that into rad 9 rad 3, which becomes negative 3 rad 3 minus 3 rad 3. And now I see I actually have like terms here. Negative 3 and negative 3 makes negative 6 rad 3 plus 4 rad 5. That's going to be my answer, and that would be D. The opposite of rad 6 can't be simplified. The opposite of rad 8 can be simplified. So I get negative rad 6 minus 2 rad 2. And let's look at 54 plus 2. Rad 54 is rad 9 rad 6, which is 2 times 3 rad 6, which is, minus 2 rad 2 plus 6 rad 6. We have like terms, negative 1 and 6, which gives me negative 2 rad 2 plus 5 rad 6. Negative 2 rad 2 plus 5 rad 6. The order does not matter, but be aware, you should be able to pick out that A is the same, that these are the same expressions. The order, there is no standard form other than your coefficient needs to go out in front of your radicals. Negative rad 2 minus 2 rad 6 can't be simplified. Negative 3 rad 8 can be simplified. Negative rad 2 minus 2 rad 6 minus 3 times 2 rad 2. Negative rad 2 minus 2 rad 6 minus 6 rad 2. We have like terms. coefficients, -1 and -6, gives me -7 rad 2 minus 2 rad 6. That would be D. Oh, again, are you aware? Did you notice the change in the format? Now we are multiplying. I'm actually going to go back. Yep, that was addition, subtraction. I didn't make a boo-boo. So when we get rad 30 times rad 21, we are not going to multiply it and make it 630. We're not going to do that. That just really is not beneficial, not efficient. That's not very efficient. What we're going to do, because we would just break this down, we'd start breaking it down into smaller radicals. So that's the reason we're somewhat broken down. Let's look and see, is there, yeah, I see a common factor amongst those. I see a 3 goes into 30 and a 3 goes into 21. And now we're playing the matching game because everything is multiplying across. So that match is good. Rad 3 times rad 3, the 3 comes out. And now we have rad 10 and rad 7. They don't have any common factors. So I'm going to multiply that and get 3 rad 70. So B. I forgot to see if I circled. Yes, I did circle. Good. All right. 3 rad 70 is my answer. 70, rad 70 cannot be simplified because I know that before I even went because there's no common factor in 10 and 7. Rad 14 times rad 7. So I'm looking to match. Can I find a factor that would match with this rad 7 from rad 14? Yeah. Rad 14 can be broken into rad 2, rad 7, which would match with that other 7, or rad 7. So we get 7 rad 2, rad 6, rad 24. So I'm going to see if I can match up that rad 6. Yes. Rad 6 times rad 4. Now I like this. This is a cool one. So not only do we get a match here, but we also got a, yes, a perfect square. So rad 6 times rad 6 produces 6. Square root of 4 is 2. So my answer is 12. That's a fun one. That's a good one. Ooh, 6 rad 12 times -5 rad 12. Now, I know it looks like we're adding and subtracting. This is a really good tricky one, but we're not. We're actually multiplying. We're multiplying these. Whoa, what happened there? We're actually multiplying these two. So we're going to multiply the outsides, which makes -30. And then, so let's do it this way. We have 6 times -5 times rad 12 times rad 12. We love this. Look, they match. So that gives me -30 times 12. The 12 comes out because we were able to match that multiplying radical. So -30 times 12 gives me -360. -360. That's another cool one. We're getting some good ones. 8 rad 8 times -6 rad 7. So rad 8, I'm going to break into rad 4 rad 2 times -6 times rad 7. We get 8 times 2 times -6 times rad 2 times rad 7. -6 times 2 is -12 times 8 is -96. And 16, 96, yep. Rad 14, because we're going to multiply rad 2 times rad 7. -96 rad 14, right there. Negative rad 5 times 8 times rad 15. negative 1 times negative 1 times rad 5 times 8 times rad 5 rad 3. We're going to match those up. We get negative 1 times 8 times 5 times rad 3, which gives me negative 40 rad 3. Negative 40 rad 3. That would be A. All right, now we have distribution, the distributive property. We're going to show that step. Show me that distribution. Show me that rad 35 times rad 15 plus rad 35 times 4. So I'm going to look. Is there a common factor? I'm going to break this up. So I'm going to make that rad 5 rad 7. Rad 15, I'm going to make rad 5 rad 3. That's for this part. That's just for this first distribution. So that turned into that. Now, we like that because we were able to match rad 5 and rad 5, which produces 5. Then we have rad 7 and rad 3, which makes rad 21. Rad 35, no perfect squares, that's already simplified. So this would be written as 4 rad 35. The 4 is on the outside, rad's on the inside. So we get 5 rad 21 plus 4 rad 35. That's a good problem to see if you really know what you're doing. It's a good test one. Distribution, rad 14 times 4 plus rad 14 times rad 6. Outside and inside, we can't combine those, so we'll just put the coefficient out front. We're going to do rad 2, rad 7. We're going to do rad 2, rad 3. Always looking for a match as the factor, common factor. We have 4 rad 14 plus 2 rad 21. 4 rad 14 plus 2 rad 21, that would be B. Rad 21 times rad 14 plus rad 21 times rad 15. So I like rad 7, rad 3, and we have rad 7, rad 2. The 7s, 7 comes out, 7 rad 6. And then the next pairing, rad 21, I'm going to rake into 3 rad 7 and, whoa, rad 3, rad 5. The 3s are going to come out, so we get plus 3 rad 35. Where's that? That would be C. Oof, negatives. Negative rad 21 times negative 8 rad 6 minus rad 21 times negative 4 rad 3. Keep track of those negatives. 3. So we're going to break this into negative rad 3 rad 7 times, well, let's put it in the parentheses. That was working. Negative 8 times rad 3 rad 2. Rad 3s, we have this negative, we have this negative in the 8 and the 3 that came out. So negative negative is positive. We have 8 times 3. And then we can't forget about the leftovers, rad 7, rad 2, which is rad 14. So that's 24 rad 14. Woo, lots of stuff to keep track of. Now let's do this next one. We have the opposite of rad 21. So let's make that rad 3, rad 7, negative 4 rad 3. The rad 3s are going to match up. And then we have the negative 4, and the 3 that came out. So that's going to be positive 4 times 3. And rad 7's the only thing left, I think. So that's plus 12 rad 7. These 14, rad 14 and rad 7 cannot be simplified. And that would be D. Nice. Woof. Look at these problems. All right, negative 6 rad 30 times negative 7 rad 3 minus 6 rad 30 times 7 rad 10. So negative 6 times negative 7 is 42. We have rad 30 and rad 3. So I'm going to break rad 30 into rad 3 times 10 times that rad 3. So we get 42 times 3 times rad 10, which is 126 rad 10. We have negative 6 times 7, which is negative 42. We have rad 30 and rad 10, so I'm going to make that rad 10 rad 3, and then the rad 10. We get 42 times 10 times rad 3, which is negative 420 rad 3. 126 rad 10 minus 420 rad 3 is B. We are doing well today. Negative 7 rad 5 times negative 8 rad 18 minus 7 rad 5 times negative 7 rad 5. Negative 7 times negative 8 gives me positive 56. Rad 5 and rad 18. Well, this is good, we haven't done this. Rad 5 doesn't have a match in rad 18. However, rad 18 has a perfect square in it. So I'm going to make that rad 9, rad 2. So that comes out, we get 56 times 3, and then these can't be matched up. So we're going to multiply that to make rad 10. That's 18, that's 168 rad 10. All right, negative 7 times negative 7 is positive 49. Rad 5 times rad 5 is 5. So 49 times 5, 45, 245. I do that right? Oh yeah. On fire. Okay, now we're on the last part of it, is division. So there's a fair number of ways. We have rad 14 over rad 50. One quick way, we can do the matching, but this time matching doesn't come out because we're talking numerators and denominators. So when we have rad 2 and rad 2, they're not being multiplied, they're being divided. So rad 2 over rad 2 cancels to make 1. This cancels to make a 1. So we have rad 7 over rad 25, and hopefully you saw that that was a perfect square. This is okay. We can have a radical in the numerator. Do we have a rad in the denom? Nope, we have a 5. So that's going to be my answer. So that is simplified. It's not a bad starting problem. Rad 2 over rad 8. Let's not rationalize first. Let's see if we can cancel. Let's see if we can simplify. Remember my 3 things. Can I simplify? Is it a perfect square? If it's not a perfect square and I can simplify it, or the third case is that it's not simplifiable. So that cancels. What do you cancel? When you cancel that thing in the numerator, what's left up there? A 1. Remember, it cancels to make 1. And then we have rad 4 in the denominator. So rad 4 is a perfect square. We get 1/2. So my answer is going to be B, 1/2. Rad 36 over rad 4. I like this one. That's fun. That's a perfect square. That's a perfect square. And we can't leave it as 6 over 2. We need to simplify all fractions. And we get C. 3 rad 56 over 8 rad 8. Well, I'm going to break 56 into 8 times 7. And I have rad 8. So these will cancel each other. That gives me 3 rad 7 over 8. And that should be my answer. 6 rad 32 over 2 rad 36. Outsides, I'm going to simplify those outsides. 6 over 2 simplifies to 3 in the numerator. Rad 32, rad 36. Well, I could break them, but I see rad 36 as a perfect square. And now I can again simplify those. That's a fraction that gets reduced to rad 32 over 2. And now I have to notice that rad 32 can be simplified. Rad 32 can be rad 16 times rad 2 over 2. And I chose 16 and 2 because 16 is a perfect square. And again, we have a fraction that can be reduced. And that gives me 2 rad 2. Wow, look at all this. That was lots of simplifying. That was a really good one too. All right, 8 rad 40 over 8 rad 9. The 8s are going to simplify to cancel to make 1. Rad 40, I'm going to break into rad 4, rad 10. Square root of 9 is a perfect square for 3. Square root of 4 is 2 rad 10 over 3. 2 rad 10 over 3. We have yet to have to rationalize a radical. And on Q, rad 7 can't be simplified, rad 6 can't be simplified. If we put them under the same radical, they can't be simplified. So I can't leave this because I have a radical in the denom. No rads in denominator. So how can I get, what gets rid of a rad 6? Another rad 6. We should know that at this point. And if I want to keep it equivalent, it has to be a value of 1. So rad 7 times rad 6, I don't see any common factors. So that's going to be rad 42. Rad 6 times rad 6 is 6. We can't simplify 42 and 6 because one's in a radical, one is out of a radical. Ooh, look at that little trickiness. Look what they did there. Those little tricksters, they gave you rad 42 over 7 and rad 42 over 6. See who's paying attention. That would be A. A is the correct answer for that one. We have 8 over rad 5. We can't have a radical in the denominator, so we are going to rationalize it. What gets rid of a rad 5 is a rad 5. And I have to multiply it by rad 5 over rad 5 because it needs to be a value of 1 to make it equivalent. Equivalent. So we get 8 rad 5 over 5, which is D. Rad 5 over rad 7. Rationalize it. Rad 7 over rad 7. We get rad 35 over 7. Oh, another tricky one. See if you're paying attention. See if you answered C. Now we have some coefficients. So 3 rad 2 over 7 rad 6. Before I rationalize, let's see if I can cancel. Rad 6 can be written as rad 2, rad 3. That gets rid of those radicals. This time they get rid of them because it's a value of 1. Leaves me with 3 over 7 rad 3. Now, I can't simplify anything else. That's simplified, but I can't leave it as my answer because I have a radical in the denominator, so I need to rationalize it. So we get 3 rad 3 over 7 times 3. We rationalize it, gets rid of that radical, but it doesn't go away. Rad 3 times rad 3 produces 3. Now we can cancel those before we multiply. And that leaves us rad 3 over 7. How nice and elegant is that answer? 8 rad 5 over 3 rad 3. I can't simplify the outsides, 8 and 3. I can't simplify the insides, so I'm going to rationalize. I'm going to multiply rad 3 over rad 3. I get 8 rad 15 over 3 times 3. And I get 8 rad 15 over 9. Am I going to jinx myself and say that I did a perfect score today? Did I not make a mistake all day? Let's simplify that. That can be reduced as a fraction. That's 3 over 2. We have rad 2, rad 3. Nothing else can cancel or simplify, but I can't leave it as my answer because I can't have a radical in the denominator. This gives me 3 rad 6 over 2 times 3. The 3's on the outside. One's in the numerator, one's in the denominator. It gives me rad 6 over 2. Did I get 100%? Yes, I did, ladies and gentlemen. Mr. McCausland. All right. That probably took about 45 minutes. Good luck. Hope this helps. We got our assessment on Thursday. Be ready.